Right now, as you watch this, something extraordinary is happening. Light that left a distant galaxy 13 billion years ago is finally reaching Earth. That light has been traveling since before our planet existed, since before our sun ignited, since before the atoms in your body were forged in the hearts of dying stars. That ancient light has crossed a distance so vast that if you could travel at the speed of a bullet, it would take you 150 trillion years to make the same journey. And yet here is the haunting truth. That light still has not crossed the entire universe, not even close, so I need you to consider something uncomfortable. Where does it all end? Does space have a wall somewhere out there, a boundary, a final edge where existence simply stops? And if it does, what could possibly be on the other side? What would you even call the place beyond everything? But wait. If space does not end, if it stretches outward forever in all directions, how can anything be truly infinite? How can there be no limit, no final destination, no edge to find no matter how far you travel? Both answers feel impossible. Both answers break something fundamental in the way our minds understand reality. And the real answer, the one that physicists and cosmologists have been piecing together for the past century, is stranger than either. It is more beautiful, more terrifying, and it might just change the way you think about your place in existence. Welcome back to Sleep Time Science, the place where we explore the deepest mysteries of the cosmos while you drift into dreams. If you are new here, consider subscribing and turning on notifications so you never miss a journey to the edge of human knowledge. For those of you returning, thank you. Thank you for being part of this community of curious minds who refuse to stop wondering about the universe we call home. Tonight, we are attempting something ambitious. We are going to travel to the edge of everything. We are going to ask the question that has haunted philosophers for millennia and physicists for the past 100 years. Does space end? Get comfortable. Adjust your pillow. Let the darkness around you become the darkness between galaxies. And let us begin. You might think this is just an abstract question for scientists and philosophers to argue about in academic journals, something interesting to ponder but ultimately disconnected from your daily life. You would be wrong. The shape and size of the universe determines fundamental truths about existence itself. If the universe is finite, then everything that exists is contained within a boundary. Resources are limited. Possibilities are limited. Time itself might have an ending written into the structure of space. But if the universe is infinite, then everything that can happen must happen somewhere. Every possible arrangement of atoms exists. Every possible history plays out. Every possible version of you is out there, living every possible life. This is not philosophy. This is mathematics. This is physics. The answer to this question determines whether you are unique in all of existence or whether infinite copies of you are scattered across an endless cosmos, some identical to you in every way, others different in ways large and small. The answer determines whether humanity has a finite future contained within walls we might someday reach, or an infinite future spread across endless space. Every atom in your body was forged in the nuclear furnaces of stars that exploded before our sun was born. Those atoms drifted through space for billions of years before becoming part of you. You are, quite literally, the universe contemplating itself. Understanding the container means understanding yourself. Understanding the shape of everything means understanding the shape of your own existence. Before we can answer whether space ends, we need to confront something humbling. We need to acknowledge our track record. Humans have been asking about the edge of reality for as long as we have been human, and we have been wrong every single time. Think about our ancestors, standing on ancient shores, staring at the horizon where the sea met the sky. They thought that was the edge. Sail too far, and you would fall off into nothingness. The horizon was the boundary of their world. Then we learned the Earth was round, and the horizon was just an illusion created by the curvature of our planet. There was no edge there at all. The ancient Greeks looked up at the night sky and saw a celestial sphere, a giant dome with stars embedded in it like diamonds pressed into dark velvet. The Earth sat at the center, and the stars marked the outer wall of existence. That sphere was the edge. It seemed obvious. It seemed self-evident. They were wrong. Copernicus and Galileo shattered that sphere. The stars were not points of light on a nearby dome. They were other suns, impossibly far away, scattered through a vast emptiness we had never imagined. The universe grew 1,000 times larger overnight. But surely the Milky Way was everything. That river of light across the night sky, that band of billions of stars, that was the entire universe. Everything that existed was contained within our galaxy. Astronomers believed this as recently as 1920. Then Edwin Hubble pointed his telescope at a fuzzy patch of light called Andromeda and discovered it was not a cloud of gas within our galaxy. It was another galaxy entirely. A separate island of billions of stars, 2 million light-years away. The universe grew 1 million times larger overnight, and it did not stop there. We now know there are 2 trillion galaxies in the observable universe. 2 trillion islands of hundreds of billions of stars each. The cosmos expanded again, beyond anything previous generations could have imagined. Do you see the pattern? Every single time humans have believed they found the edge of reality, they were wrong. Every single time we thought we reached the boundary, we discovered it was not a boundary at all. The horizon was not the edge of the world. The celestial sphere was not the wall of heaven. The Milky Way was not the entire cosmos. We have a perfect track record of being wrong about the size of the universe. Every single time, without exception, the universe turned out to be larger than we thought. So when we ask, does space end, we should approach the question with humility. We should remember that the universe has surprised us before, and it will almost certainly surprise us again. Now, before we go further, I need to clarify something important. When people ask, does space end, they are usually conflating 3 separate questions that have 3 different answers. The first question is, does the observable universe have an edge? The second question is, does the entire universe have an edge? The third question is whether there is anything beyond the universe. These sound similar, but they are profoundly different, and confusing them leads to endless misunderstanding. Let me explain each one. The observable universe is everything we can see and detect. It has a definite boundary, and we know exactly where that boundary is. The answer to the first question is yes, absolutely, the observable universe has an edge. The entire universe is everything that exists, whether we can see it or not. This includes regions of space so far away that light from them has not had time to reach us since the beginning of time. Does this have an edge? We genuinely do not know. We have theories, we have evidence that points in certain directions, but we cannot be certain. The third question asks if there is anything beyond the universe, anything outside of existence itself. This question might not even make sense. It might be like asking what is north of the North Pole. The question assumes a framework that simply does not apply. We are going to explore all 3 of these questions tonight. We will start with what we know for certain, move into what we strongly suspect, and end with what remains mysterious. Along the way, I think you will find that reality is stranger and more wonderful than anything we could have invented. Let us begin with what we actually know. The observable universe has an edge, and we can tell you exactly where it is. But to understand this edge, you first need to understand something that changes everything. Light has a speed limit. Nothing in the universe can travel faster than light. Not rockets, not information, not even gravity itself. Light moves at 299,792 kilometers per second. That sounds unimaginably fast, and it is. At that speed, you could circle the Earth 7.5 times in a single second. You could reach the Moon in just over 1 second. You could reach Mars in about 3 minutes when it is closest to Earth. But here is where things get strange. The universe is not small. The universe is so incomprehensibly vast that even light, traveling at this incredible speed, takes years to cross the gaps between stars. The nearest star to our Sun is Proxima Centauri, and it is 4.24 light-years away. That means light leaving Proxima Centauri right now will not reach Earth for more than 4 years. When you look at that star in the night sky, you are not seeing it as it is now. You are seeing it as it was 4 years ago. You are looking back in time. This is not poetry. This is not metaphor. This is literal truth. Every time you look at a distant object in space, you are seeing the past. The further away something is, the deeper into the past you are looking. When you look at the Andromeda Galaxy, you are seeing light that left 2.5 million years ago, when our ancestors were just beginning to use stone tools. When the Hubble telescope photographs galaxies billions of light-years away, it is photographing the universe as it was billions of years ago, long before Earth existed. Now here is the crucial insight. The universe has an age. It is 13.8 billion years old. Before that, there was no universe, at least not in any form we would recognize. Time itself began with the Big Bang. This means light has only had 13.8 billion years to travel through space. Light from objects further than 13.8 billion light-years away simply has not had enough time to reach us yet. It is still on its way. This creates a boundary, not a physical wall, but a horizon of visibility. Imagine standing in a thick fog. You can only see perhaps 100 meters in any direction. Everything beyond that distance is hidden from you, swallowed by the white mist. But you know the world does not end at 100 meters. There are trees and buildings and cities beyond the fog. You simply cannot see them. The observable universe works exactly like this. We are surrounded by a cosmic fog of distance and time. We can only see so far, not because space ends there, but because light from further away has not reached us yet. And some of it never will. But wait, you might be thinking. If the universe is 13.8 billion years old, and light has been traveling since the beginning, then the observable universe should be 13.8 billion light-years in radius. That would make sense, that would be logical, but the actual number is much larger. The observable universe is 46.5 billion light-years in radius. That is 93 billion light-years from edge to edge. How is this possible? How can we see things 46 billion light-years away in a universe that is only 13.8 billion years old? The answer is one of the most mind-bending discoveries in all of cosmology. Space itself is expanding, not just the objects in space moving apart, but the actual fabric of space stretching like the surface of an inflating balloon. When light left a distant galaxy 13 billion years ago, that galaxy was much closer to us. But while the light was traveling toward Earth, space itself was stretching. The galaxy was being carried further away by the expansion of space. By the time that ancient light finally reaches our telescopes, the galaxy that emitted it is now much, much further than 13 billion light-years. It has been carried outward by the expanding universe. This is why the observable universe is larger than the age of the universe multiplied by the speed of light. Space has been stretching the entire time. The photons were running toward us on a treadmill that was constantly extending beneath them. Now let us talk about the farthest thing we can actually see. It is not a galaxy. It is not a star. It is something far more ancient and far more strange. It is called the cosmic microwave background, and it is the afterglow of the Big Bang itself. In the first 380,000 years after the universe began, everything was unimaginably hot. The entire cosmos was a dense, opaque plasma, a roiling sea of particles and energy where light could not travel freely. Photons would scatter off particles almost immediately, like trying to see through a thick storm of white snow. Then 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Suddenly, space became transparent. Light could finally travel in straight lines. The first photons to escape from that cosmic fog have been traveling ever since. For 13.8 billion years, those ancient photons have been crossing the universe. And some of them are reaching Earth right now, entering our radio telescopes, telling us about the infant universe. When we map the cosmic microwave background, we are seeing a wall, not a wall in space, but a wall in time. We are seeing the moment the universe became transparent, the moment light was first set free. We cannot see beyond this wall because there is no light from before it. The universe was opaque. The information is simply not available. This wall surrounds us in every direction. No matter which way we point our telescopes, we see this same ancient light, this same cosmic baby picture. We are inside a sphere of visibility, and the cosmic microwave background marks its outer boundary. Beyond it, there is more universe. We know this with certainty. Space does not end at the cosmic microwave background. But we cannot see what lies beyond. We never will. That light will never reach us because it does not exist. The universe was opaque, and no photons escaped to tell the tale. Let me give you a sense of scale, because numbers alone cannot capture what we are discussing. The observable universe contains approximately 2 trillion galaxies, not 2 trillion stars. 2 trillion galaxies, each containing hundreds of billions of stars. If you counted 1 star per second, it would take you over 100 trillion years to count all the stars in the observable universe. That is thousands of times longer than the universe has existed. There are more stars in the observable universe than grains of sand on every beach on Earth. More stars than words that have ever been spoken by every human who has ever lived. The observable universe spans 93 billion light-years. If you could somehow travel at the speed of light, it would take you 93 billion years to cross from one side to the other. But you could not actually make that journey, because while you were traveling, space would keep expanding. The finish line would keep moving further away. You would be running a race you could never win. And here is perhaps the most haunting fact of all. The edge of the observable universe is not staying still. Every second, more of the universe slips beyond our cosmic horizon. Distant galaxies are being carried away from us by the expansion of space, and some are receding faster than the speed of light. This does not violate Einstein's relativity, because the galaxies are not moving through space faster than light. Space itself is expanding, carrying them along like raisins in rising bread dough. Galaxies we can see today will eventually fade from view. Their light will stretch into longer and longer wavelengths as space expands, shifting from visible light to infrared to microwave to radio waves, and eventually becoming undetectable. They will redshift into invisibility, disappearing from our universe forever. In the far future, trillions of years from now, astronomers on some distant world might look up at their sky and see nothing but their local cluster of galaxies. Everything else will have faded beyond the horizon. They will have no way of knowing that trillions of other galaxies once filled the cosmos. They will look at an empty sky and conclude, perhaps, that their small cluster is all that exists. They will be wrong, just as our ancestors were wrong about the celestial sphere, but they will have no evidence to tell them otherwise. The universe will have hidden itself from them. We are living in a special time. A window of cosmic history where we can still see the evidence of the Big Bang, where we can still detect distant galaxies, where we can still piece together the story of the universe. That window is slowly closing. The edge is pulling away. And we are watching the universe isolate itself, one galaxy at a time. So this is the observable universe, a sphere of visibility 93 billion light-years across, containing 2 trillion galaxies and more stars than we could ever count. It has a definite edge, a horizon created by the finite speed of light and the finite age of the universe. But here is what I need you to understand before we move forward. The observable universe is not the entire universe. It is just the part we can see. Think back to the fog analogy. You can see 100 meters in every direction. Your observable world is a sphere with a radius of 100 meters. But you know the real world extends far beyond that fog. There are continents and oceans you cannot see. There are mountains and deserts hidden from your view. The fog creates a boundary to your observation, not a boundary to reality. The same is true for the cosmos. The observable universe is our cosmic fog limit. Beyond it lies more space, more galaxies, more stars. How much more? That is the question we turn to now. Because when we ask, does space end, we are really asking about what lies beyond the horizon. We are asking about the parts we cannot see and never will see. We are asking about the shape of everything. To understand whether the entire universe has an edge, we need to think about something that seems abstract but is actually deeply physical. We need to think about the geometry of space itself. When you draw a triangle on a flat piece of paper, the angles inside that triangle always add up to 180 degrees. Always. This is basic geometry, the kind you learned in school, but here is something your teachers may not have told you. That rule only works on flat surfaces. If you draw a triangle on the surface of a sphere, something strange happens. The angles add up to more than 180 degrees. Imagine drawing a triangle on a globe. Start at the North Pole, draw a line straight down to the equator, turn 90 degrees and walk along the equator for a quarter of the way around the Earth, then turn 90 degrees and walk straight back to the North Pole. You have drawn a triangle with 3 90-degree angles. That is 270 degrees, not 180. The geometry of a curved surface is different from the geometry of a flat surface. Now imagine drawing a triangle on a saddle shape, a surface that curves downward in one direction and upward in another. On this kind of surface, the angles of a triangle add up to less than 180 degrees. The surface curves away from itself and the geometry warps accordingly. Here is the profound insight that Einstein gave us. Space itself can be curved, not just the surfaces of objects in space, but the fabric of space itself, the three-dimensional arena in which everything exists. Just as a two-dimensional surface can be flat, spherical, or saddle-shaped, three-dimensional space can have analogous geometries, and the geometry of space determines whether the universe has an edge. Einstein's equations of general relativity tell us that the shape of space is determined by the amount of matter and energy it contains. More stuff means more gravity, which means more curvature. The universe can have one of 3 basic geometries, and each one has different implications for whether space ends. The first possibility is positive curvature. In this scenario, space curves back on itself like the surface of a sphere, but in 3 dimensions instead of 2. If you could travel far enough in any direction, you would eventually return to where you started, just like circumnavigating the Earth. This kind of universe is finite. It has a definite size, a total volume you could measure. But here is the crucial point. It has no edge. Just as the surface of a sphere has no boundary, no place where it stops, a positively curved universe would have no wall, no endpoint, no place where space itself terminates. You could travel forever without hitting an edge. You would simply keep looping through the same finite space. This is what mathematicians call finite but unbounded. It is finite in size but has no boundary. It is like the surface of the Earth. You can measure the surface area of Earth. It is finite, but if you walk across it, you never reach an edge. You never fall off. You just keep going until you return to where you began. The second possibility is negative curvature. In this scenario, space curves like an infinite saddle spreading outward forever in all directions. This kind of universe is infinite. It has no total volume because volume extends without limit. It obviously has no edge because infinity has no boundary by definition. You could travel forever in any direction and never reach an end, never loop back, never encounter anything but more space stretching out ahead of you. The third possibility is zero curvature. Space is flat, like an infinite sheet of paper extending forever in all directions. This universe is also infinite, also without edge, also extending without limit. The difference between flat and negatively curved space is subtle and has to do with how parallel lines behave and how triangles add up, but both are infinite and boundaryless. So which is our universe? This is not a philosophical question. This is something we can measure, and we have measured it with extraordinary precision. The key is the cosmic microwave background, that ancient light from 380,000 years after the Big Bang. That light contains tiny temperature fluctuations, spots that are slightly hotter or slightly cooler than average. These fluctuations are like ripples in a pond, and they have a characteristic size. We know how big these ripples should appear based on the physics of the early universe. If space is positively curved, like the surface of a sphere, those ripples would appear magnified, stretched larger than they should be. If space is negatively curved, like a saddle, the ripples would appear shrunk, compressed smaller than expected. If space is flat, the ripples would appear exactly the size we calculate they should be. Satellites like COBE, WMAP, and Planck have measured these fluctuations with incredible precision. They have mapped the cosmic microwave background in exquisite detail, measuring temperature differences of 1 part in 100,000. And the verdict is in: the universe is flat. To within 0.4% precision, space has zero curvature. The fluctuations appear exactly the size they should if space is flat. This is an extraordinary result. It suggests that the universe might be infinite, extending forever in all directions without edge or boundary. But I need to be careful here, because flatness does not prove infinity. There are ways a universe can be flat and still be finite. We will explore those possibilities in a moment. But first, I want you to appreciate how strange this flatness is. For the universe to be this flat today, it had to be almost impossibly flat at the very beginning. This is called the flatness problem, and it is one of the deepest puzzles in cosmology. Here is the issue: curvature changes over time. As the universe expands, any initial curvature gets amplified. A universe that starts with even a tiny amount of positive or negative curvature will become more curved as it ages. It is like balancing a pencil on its tip. If the pencil is even slightly off balance, it will fall. The longer you wait, the more it tilts. For the universe to be as flat as we measure it today, after 13.8 billion years of expansion, it had to be balanced to an almost miraculous degree at the beginning. Calculations show that 1 second after the Big Bang, the universe had to be flat to within 1 part in 10 to the 60th power. That is a 1 with 60 zeros after it. That is a precision so extreme it defies comprehension. It is like throwing a dart from Earth and hitting a target the size of an atom on the other side of the galaxy. Why would the universe start in such an impossibly fine-tuned state? This seemed like an absurd coincidence until physicists developed a theory that explains it beautifully. That theory is called inflation, and it will become central to our story when we explore what lies beyond the observable universe. But for now, just remember that the flatness of space is both a measured fact and a profound mystery. The universe is flat, and that flatness requires explanation. Now, I mentioned that a flat universe could still be finite, and this brings us to one of the strangest possibilities in cosmology. The shape of space is not just about curvature. It is also about topology, the way space connects to itself. Imagine a video game from the 1980s where the screen wraps around. If your spaceship flies off the right edge of the screen, it reappears on the left edge. If it flies off the top, it reappears at the bottom. The screen is flat. There is no curvature, but it is also finite. It has a definite area. And yet there are no edges. You can fly forever without hitting a wall. You just pass through the same space over and over. This is called a torus, a donut shape. The surface of a video game screen has the topology of a torus. It is flat, finite, and unbounded all at once. The universe could be similar. It could be flat on small scales, obeying all the geometry we measure, but wrapped around on itself in a three-dimensional version of a torus. Space would be finite in total volume, but you could travel forever without hitting an edge. You would simply keep passing through the same regions again and again, perhaps without even realizing it. There are many possible topologies, many ways space could connect to itself. Some are orientable, meaning left and right stay consistent as you travel. Others are non-orientable, meaning you could travel in a straight line and come back mirror reversed, your heart on the wrong side of your chest. Scientists have searched for evidence of cosmic topology by looking for repeating patterns in the cosmic microwave background. If space wraps around, we might see the same distant regions from two different directions, like seeing the back of your own head in a hall of mirrors. So far, we have found nothing. If the universe has a complex topology, if it wraps around on itself, it does so on scales larger than the observable universe. We are inside the repeating pattern, and it is too big for us to see the repetition. This means one of two things. Either the universe is truly infinite, extending forever without any wrapping or repetition, or it is finite but so large that the finite nature is hidden from us, perhaps forever. Either way, we cannot reach an edge. Either way, there is no wall to find. Now we enter territory that will stretch your imagination to its breaking point. We have talked about the observable universe, the sphere of visibility 93 billion light-years across. We have talked about the geometry of space, how it appears to be flat, extending perhaps infinitely in all directions. But now we need to talk about what happened in the first fraction of a second after the Big Bang. We need to talk about inflation. And when you understand inflation, you will understand why the universe beyond what we can see might be so large that the word large loses all meaning. In the standard Big Bang model, the universe began as an incredibly hot, dense state and has been expanding ever since. But the standard model had problems. It could not explain why the universe is so flat. It could not explain why the cosmic microwave background looks the same temperature in every direction, even in regions that should never have been in contact with each other. It could not explain why we do not see certain exotic particles that should have been produced in the early universe. In 1980, a physicist named Alan Guth proposed a radical solution. He suggested that in the first unimaginably tiny fraction of a second after the Big Bang, the universe underwent a period of exponential expansion. Not the gradual expansion we see today, but a violent, runaway inflation that stretched space faster than the speed of light. We are talking about timescales so small they defy comprehension. Inflation began about 10 to the negative 36 seconds after the Big Bang. That is a decimal point followed by 35 zeros and then a 1. In that brief instant, shorter than any time interval you could ever measure, space expanded by a factor of at least 10 to the 26th power. The universe grew from something smaller than a proton to something larger than the entire observable universe today. All in less time than it takes light to cross a single atom. This solves the flatness problem beautifully. Imagine the surface of a balloon. When the balloon is small, you can see its curvature clearly. But if you inflate that balloon to the size of the Earth, any small patch of its surface appears flat. The curvature is still there, but it has been stretched so thin that it becomes undetectable. Inflation did the same thing to space. Whatever curvature the universe started with was stretched so dramatically that space became flat to that impossibly precise degree we observe today. The flatness is not a miraculous coincidence. It is a natural consequence of inflation. Inflation also explains why the cosmic microwave background looks uniform. Before inflation, the entire observable universe was contained in a region smaller than an atom. Everything was in contact. Everything could reach thermal equilibrium, the same temperature everywhere. Then inflation stretched that tiny, uniform region to cosmic scales. The uniformity we see is a fossil of that ancient contact, preserved and magnified by inflationary expansion. But here is where things get truly staggering. If inflation happened, and the evidence strongly suggests it did, then the universe beyond what we can see is not just a little bigger than the observable universe. It is incomprehensibly bigger. Some calculations suggest the entire universe is at least 10 to the 23rd times larger than the observable universe. That means for every atom in the observable universe, there might be an entire observable universe worth of space beyond our horizon. Other calculations are even more extreme. Some models of inflation suggest the universe could be 10 to the 10 to the 10 to the 122 times larger than what we can see. I cannot even help you visualize that number. It is a tower of exponents, each one representing a power of 10, stacked upon each other until the result transcends any quantity that has ever been named or contemplated. Now I need you to sit with an implication that follows from this. If the universe is truly this large, or if it is infinite, then something remarkable and unsettling must be true. In an infinite universe, every possible arrangement of matter exists somewhere. Let me explain. There are only so many ways to arrange atoms within any given region of space. The number is vast, incomprehensibly vast, but it is finite. If you have a box 1 meter on each side, there are only so many ways to arrange the particles inside that box according to the laws of physics. Now imagine an infinite universe, or even a universe 10 to the 10 to the 122 times larger than what we can observe. Eventually, by pure statistics, every possible arrangement must occur. Just as a monkey typing randomly on a keyboard will eventually type the complete works of Shakespeare if given infinite time, an infinite universe will eventually contain every possible configuration of matter. This means somewhere out there, beyond the cosmic horizon, there is a region of space identical to our observable universe. Not similar, identical. Every galaxy in the same position, every star with the same planets. Every planet with the same continents, the same cities, the same people. There is another Earth out there, with another you, living an identical life. And not just one copy, infinite copies. And beyond those identical copies, there are near copies, versions of you who made different choices. Versions where you took a different job, lived in a different city, never watched this video. Versions where small quantum fluctuations led to different thoughts in your brain, different words from your mouth, different paths through life. This is not mysticism. This is not science fiction. This is the mathematical consequence of the physics we observe. If inflation is correct, and if the universe is large enough or infinite, then every possible version of reality exists somewhere. You are not unique. You are one of infinite copies, each believing themselves to be the only one. But inflation might be even stranger than this. Some physicists believe that inflation is not a one-time event that happened and ended. They believe inflation is eternal. Here is the idea. Inflation is driven by a quantum field called the inflating field. As this field decays, it releases energy that becomes the matter and radiation we see around us. Inflation ends when the field decays completely, but quantum mechanics introduces randomness. The inflating field does not decay everywhere at the same rate. In some regions, it decays quickly, ending inflation and creating a pocket of normal space like our universe. In other regions, quantum fluctuations keep the field energized, and inflation continues. And here is the key insight. The regions that keep inflating expand exponentially. They grow faster than the pockets where inflation has ended. Even if most of the inflating space decays into normal universes, the remaining inflating space grows so fast that it always dominates. Inflation never truly ends. It keeps going forever, constantly spawning new pocket universes like bubbles in an infinite foam. Our universe would be just one bubble in this cosmic froth. Beyond our bubble, beyond even the impossibly large universe created by our own inflation, there would be other bubbles, other pocket universes, each with their own Big Bang, their own expansion, their own history. And between these bubbles, inflation continues forever, creating new bubbles for eternity. Some of these pocket universes might have the same physical laws as ours. Others might be radically different. The strength of gravity, the mass of electrons, the speed of light itself might vary from bubble to bubble. There could be universes where atoms cannot form, where stars cannot ignite, where life is impossible. There could be universes with physics we cannot even imagine, dimensions we cannot perceive, forces we have no names for. This is the multiverse, the idea that our universe is not all that exists, that beyond our cosmic horizon lies not just more space but other spaces entirely, other realities governed by other rules, forever beyond our reach. We cannot prove the multiverse exists. We may never be able to prove it. The other pocket universes are beyond our observable horizon and always will be. But if inflation is eternal, and many physicists believe it is, then the multiverse is not speculation. It is a prediction. It is what the mathematics tells us must be true. Now we arrive at the deepest and most difficult part of our journey. We have established what we know. The observable universe has a boundary, a horizon of light beyond which we cannot see. We have explored what we suspect. The entire universe is likely far larger than what we observe, possibly infinite, possibly one bubble among infinite bubbles in an eternally inflating multiverse. But now we must confront what we cannot know. We must ask whether there are limits not just to the universe, but to knowledge itself. First, let us be honest about the difference between established science and informed speculation. We know the observable universe exists. We have photographed it, measured it, mapped its structure and history. The observable universe is as real as the device you are using to watch this video. We are confident that inflation occurred. The evidence is strong. Inflation explains the flatness of space, the uniformity of the cosmic microwave background, the distribution of galaxies, and other features of the cosmos that would otherwise be mysterious coincidences. Most cosmologists accept inflation as the best current model of the early universe, but we do not know if the universe is truly infinite. We do not know if it has a complex topology that wraps around on itself. We do not know if eternal inflation is correct or if the multiverse exists. These are extrapolations from our theories, logical consequences of the mathematics, but they may never be directly testable. Some of these questions might be permanently beyond our reach. The edge of the observable universe is not just far away, it is receding. The expansion of space is accelerating, carrying distant galaxies away from us faster and faster. In the far future, the cosmic horizon will shrink. We will see less and less of the universe, not more. We are not approaching an era of complete cosmic knowledge. We are watching the evidence disappear. This brings us to a philosophical puzzle that has haunted thinkers for millennia. What does it even mean to ask what lies beyond the universe? If the universe is defined as everything that exists, then by definition there cannot be anything beyond it. The question contains its own answer. Asking what is outside the universe is like asking what is north of the North Pole. The question assumes a framework that does not apply. North is a direction defined by the Earth's surface. At the North Pole, every direction is south. The concept of north simply does not extend beyond that point. It is not that there is nothing north of the North Pole. It is that the question itself becomes meaningless. Similarly, space and time might have begun with the Big Bang. There might not have been a before the Big Bang because time itself did not exist. There might not be anything outside the universe because space itself does not extend beyond it. Our language evolved to describe a world of edges and containers. We talk about inside and outside, before and after, bounded and unbounded. These concepts work beautifully for everyday life. They work for boxes and rooms and planetary surfaces, but they may not work for the universe as a whole. The universe might not be a thing inside a larger container. It might be all there is, a self-contained totality that does not require an outside to make sense. When we ask, does space end, we might be asking a question that the universe is not obligated to answer, because the question itself is based on assumptions that do not apply at cosmic scales. I want to close this section with a reflection on the limits of human comprehension. Our brains evolved on the African savanna over millions of years. They evolved to help us find food, avoid predators, navigate social relationships, and survive long enough to reproduce. They did not evolve to comprehend infinity. They did not evolve to visualize curved spacetime or understand quantum mechanics or grasp the true scale of the cosmos. When we ask about the edge of the universe, we are asking our hunter-gatherer brains to process something they were never designed for. We are using mental tools shaped by tracking antelope across grasslands to contemplate the structure of everything. This is not a criticism of human intelligence. It is a statement of wonder that we have gotten as far as we have. It is remarkable that creatures like us, animals on a small planet orbiting an ordinary star, have been able to deduce so much about the cosmos. We have measured the age of the universe. We have mapped the distribution of billions of galaxies. We have traced the history of space and time back to a fraction of a second after the beginning. But we should be humble about what remains beyond us. A flatworm has no concept of tomorrow. It cannot understand the passage of time or plan for the future. These concepts are simply beyond its neural architecture. We might be flatworms when it comes to infinity. We might be creatures whose brains cannot, even in principle, fully grasp what it would mean for space to never end. We can write equations. We can follow logical arguments. We can use mathematics as a tool to extend our reach beyond our intuitions. But true understanding, the kind that feels natural and obvious, might be permanently out of reach. The universe is under no obligation to be comprehensible to us. It is under no obligation to have edges we can find or infinities we can grasp. It is under no obligation to fit neatly into the categories our minds evolved to use. It simply is what it is, and we are small things inside it, doing our best to understand, reaching toward truths that may always remain just beyond our grasp. That reaching is beautiful. That curiosity is what makes us human. But the humility to accept what we cannot know, that might be the deepest wisdom of all. We have traveled far together tonight. We have journeyed from the ancient shores where our ancestors stared at the horizon believing it to be the edge of the world, all the way to the bleeding edge of modern cosmology, where physicists contemplate infinite multiverses and eternally inflating spacetime. We have crossed billions of light years and billions of years. We have watched the universe expand and evolve and hide itself from view. Now it is time to bring our journey home. Let us remember what we have learned. We asked 3 questions at the beginning of this exploration. Does the observable universe have an edge? Does the entire universe have an edge? And is there anything beyond the universe? The first question has a definite answer, and that answer is yes. The observable universe has a boundary, a cosmic horizon located 46.5 billion light-years away in every direction. This is not a physical wall. It is a horizon of visibility, created by the finite speed of light and the finite age of the cosmos. Light from beyond this horizon has not had time to reach us since the universe began. We are surrounded by a sphere of visibility, and beyond that sphere lies more universe that we cannot see and will never see. The cosmic microwave background marks the farthest edge of this visible realm, the ancient light from 380,000 years after the Big Bang, the moment when the universe first became transparent. Before that moment, the cosmos was an opaque fog of hot plasma, and no light escaped to tell us what came before. We are inside a bubble of knowable history, and that bubble has a definite size. The second question is more uncertain, and the honest answer is that we do not know for certain whether the entire universe has an edge, but we have strong reasons to believe it does not. The geometry of space appears to be flat, extending without curvature in all directions. A flat universe, if it is simply connected, extends infinitely. There would be no edge, no boundary, no wall where space stops. You could travel forever in any direction and never reach an end. If the universe has a complex topology, if it wraps around on itself like the surface of a video game screen, then it might be finite in total volume. But even then, there would be no edge. You would travel through the same space again and again, looping eternally without ever hitting a boundary, finite but unbounded like the surface of the Earth. Either way, there is no wall to find. Either way, space does not stop. The universe does not have an edge in the way our intuitions suggest it should. There is no place where existence ends and nothingness begins. There is no boundary sign reading you have reached the end of space. Turn back now. Inflation suggests the universe beyond our horizon is incomprehensibly vast, possibly 10 to the 23rd times larger than everything we can observe, possibly even larger than that, possibly infinite. If eternal inflation is correct, our universe might be one bubble in an endless foam of pocket universes, each with its own laws of physics, each forever isolated from the others, each a separate reality unto itself. The third question might not have an answer at all, at least not an answer that fits into human language and human concepts. What lies beyond the universe? If the universe is everything that exists, then nothing lies beyond it by definition. The question assumes that the universe is a thing inside a larger container, but that assumption might be wrong. Space and time might have begun with the Big Bang. There might not have been a before because time itself did not exist before the beginning. There might not be an outside because space itself does not extend beyond the cosmos. Asking what is outside the universe might be like asking what is north of the North Pole or what is the color of jealousy. The question uses concepts that do not apply. But if the multiverse is real, if eternal inflation endlessly spawns new pocket universes in an infinite cosmic foam, then in some sense there is something beyond our universe. There are other universes, other bubbles of spacetime, other realities entirely. They are not beyond our universe in the sense of being further away in space. They are beyond in a deeper sense, separated from us by inflating spacetime that we can never cross, existing in a framework larger than any single universe. We will almost certainly never prove the multiverse exists. The other pocket universes are causally disconnected from us, forever beyond any possible observation or measurement, but the mathematics points toward their existence. The logic of inflation suggests they must be there. We might be one island of reality in an archipelago of infinite islands, each isolated, each complete unto itself, each home to its own version of physics and history, and perhaps life. So does space end? The deepest answer I can give you is this. Space does not end in any way that would be familiar or comfortable to our human minds. There is no wall, there is no boundary. There is no place where you would bump into the edge of existence. If space is infinite, it stretches forever, and the concept of an edge does not apply to infinity. If space is finite, it wraps around on itself, and you would travel forever in loops without ever reaching a stopping point. The observable universe has a horizon, but that is a limit of our vision, not a limit of reality. Beyond that horizon lies more space, more galaxies, more stars, more possibilities than we could ever count or comprehend. And beyond even that, perhaps, lie other universes entirely, other realities, other versions of everything. We began this journey with an uncomfortable choice. Either space ends, and something impossible lies beyond the wall. Or space never ends, and infinity stretches in all directions. Both answers felt impossible, and now you see why. Both answers were based on assumptions that the universe does not share. The universe does not owe us edges. It does not owe us comprehensibility. It simply is, vast beyond measure, strange beyond intuition, beautiful beyond description. I want to leave you with something to carry into your dreams tonight. When you close your eyes, when the darkness surrounds you, remember that the darkness between galaxies is that same darkness. The emptiness you see behind your eyelids is kin to the emptiness that stretches across billions of light years. You are not separate from the cosmos. You are part of it. Every atom in your body was forged in the heart of a star that died before our sun was born. The iron in your blood, the calcium in your bones, the oxygen you are breathing right now, all of it was cooked in nuclear furnaces scattered across this galaxy and sent drifting through space by supernova explosions. You are stardust that has come to life. You are the universe awakened, looking back at itself, wondering about its own edges. And that wondering, that curiosity, that refusal to stop asking questions, that might be the most remarkable thing in all of existence. In the entire cosmos, across billions of galaxies and trillions of stars, you are a place where the universe has become conscious of itself. You are matter that has learned to ask, where does matter end? You are space that has learned to ask, does space end? That is precious beyond measure. That is rare beyond calculation. Whatever the answer to our question, whether space extends forever or wraps around or spawns infinite multiverses, you are here, now, aware, wondering. That is the miracle, not the size of the universe or its shape or its edge or its infinity. The miracle is that anything in the universe cares about these questions at all. The miracle is you. Tonight, when you look up at the stars, if you can see them from where you are, remember what you have learned. The light entering your eyes has been traveling for years, for centuries, for millennia. Some of it has been traveling since before life existed on Earth. You are seeing the past painted across the sky, history written in photons, stories told by dying stars. And beyond the farthest light you can see, there is more. How much more, we do not know, we might never know, but we know it is there. We know the universe extends beyond our vision, beyond our reach, beyond perhaps our comprehension. And that is not a failure of human knowledge. That is an invitation to keep looking, to keep asking, to keep wondering. The edge of our knowledge is where science lives. Every unanswered question is an opportunity for someone watching this video to someday find the answer. Maybe that someone is you. Maybe you will be the one who discovers a new way to test inflation, a new method to probe the topology of space, a new theory that explains what lies beyond the beyond. The universe has surprised us before. It will surprise us again, and you might be part of that surprise. So here is my final thought for you tonight, the question I want you to carry with you as you drift towards sleep. If the universe is infinite, or even if it is simply unimaginably vast, then every possible arrangement of matter exists somewhere. Every possible configuration of atoms, every possible history, every possible version of events. Somewhere out there, in a region of space we will never see, there is another Earth orbiting another sun in another galaxy, impossibly far away. On that Earth, there is another you. Perhaps that other you is also watching a video about whether space ends. Perhaps they are also lying in the darkness, eyes heavy with sleep, mind expanded by the vastness of it all. Perhaps they are thinking the same thoughts you are thinking right now, or perhaps not. Perhaps in their universe they made different choices. Perhaps they never found this channel. Perhaps they're living a life you almost lived, a path you almost took, a version of yourself you almost became. If the universe is large enough, all of these versions exist. All of these possibilities are real. You are not alone in your wondering. Across the cosmos, infinite minds are asking infinite questions, each one a mirror of the others, each one unique, each one precious. And somewhere, some version of you has already found the answer. Somewhere the question has been resolved, the mystery has been solved, the edge has been found or proven not to exist. That knowledge exists somewhere in the universe. We simply have not reached it yet. Thank you for taking this journey with me tonight. Thank you for your curiosity, your patience, your willingness to stretch your mind across billions of light years and contemplate ideas that strain the limits of human thought. This is Sleep Time Science, and I hope that as you drift into dreams, the vastness of the cosmos brings you not fear but wonder, not anxiety but peace. You are small against the scale of the universe, that is true. But you are also connected to all of it, made of the same stuff, governed by the same laws, part of the same unfolding story that began 13.8 billion years ago and will continue long after our sun has burned out and our galaxy has merged with Andromeda and the stars themselves have faded into darkness. You are a chapter in that story, a brief chapter perhaps, a single page, but a chapter nonetheless, and your chapter matters because you are here to read it, because you are here to ask what comes next, because you are here to wonder whether the story has an ending or whether it goes on forever, page after page, chapter after chapter, universe after universe without end. Sleep well, my friend. Dream of stars and galaxies and the spaces between them. Dream of light traveling across billions of years to reach your eyes. Dream of the edge of everything and the everything beyond the edge. And when you wake, remember that the universe is still out there, still expanding, still full of mysteries waiting to be discovered. One of them might be waiting for you. If you found this journey meaningful, if these ideas sparked something in your mind, please consider subscribing to Sleep Time Science. Hit the notification bell so you never miss another exploration of the cosmos. Leave a comment below telling me what you think about the edge of space. Do you believe the universe is infinite? Do you find comfort in the vastness, or does it fill you with existential dread? Do you think we will ever know for certain whether space ends or goes on forever? I read every comment, and I love hearing your thoughts. Your perspectives, your questions, your insights make this community special. Share this video with someone who loves to wonder about the big questions. Share it with someone who needs to be reminded how vast and beautiful the universe is. Share it with someone who might be lying awake tonight, staring at the ceiling, feeling small and insignificant, not yet knowing that their smallness is actually a kind of miracle, that their insignificance is actually participation in something infinite. We are all in this together, all of us wondering, all of us reaching toward answers we might never fully grasp. And that reaching, that shared curiosity, that collective wonder, that is what makes us human. That is what makes the universe worth contemplating. That is what makes these questions worth asking, even when the answers remain forever just beyond our reach. The universe may or may not have an edge. But your journey to understand it has no limits. Keep wondering, keep asking, keep looking up, and I will see you in the next video where we will explore another mystery at the edge of human knowledge. Until then, sleep well, dream deeply. And remember, you are the universe experiencing itself, wondering about itself, marveling at itself. That is the greatest mystery of all. Good night.